Hello everyone, my name is Komasinyolo. Welcome to another video by Attention Matrix, where we try to make learning fun and easy. Please comment, like, and subscribe if you would like us to continue making this content and you enjoy it or find it helpful. Now on to the next video. Let's get right into it.
Hello everyone, in this video we will be continuing with our lessons on naming hydrocarbons. Up to this point we've only been focusing on naming aliphatic compounds. So if I scroll up, these are the aliphatic compounds that we looked at. We looked at alkanes, we looked at alkenes, and we looked at alkynes, and we looked at what distinguishes these aliphatic compounds, which is the number of bonds between two successive carbon atoms. That's what distinguishes the compounds from one another. We looked at what structural isomers are, and we know that structural isomers from a previous video. If you haven't watched that video, I highly recommend that you pause this one and you go watch the previous video. We discussed that structural isomers are hydrocarbons where the molecular formula is the same, but the structure of the compounds is different, right? So you've got two compounds with identical molecular formulae but different structural formula, different structural makeups, right? We looked at aliphatic compounds, we looked at what structural isomers are, and we looked at what functional groups are, and we studied these three groups as our simplest functional groups, right? And we said we explained what functional groups are in the previous video. We described how they differ, and we went in a bit more detail with a couple of examples. We used this table, we used this table a bit further. We covered a number of examples in the previous video to illustrate the concepts much better. Right, so in this video we will be looking at what we call alkyl groups. Now, alkyl groups is another type of a functional group. Okay, so we looked at functional groups in a previous video, and then the next type of functional group that we're going to look at is the alkyl groups. Okay, now what are alkyl groups? I'm going to explain them in the form of an example. So let's say you've got a compound, right? You've got C, a hydrocarbon, C, and then we've got 4 bonds around all the carbons. We've got 4 bonds around all the carbons. And here we've got C, we've got H, and we've got H. Okay, now in these compounds, you will remember from previous videos that we have what we call parent chains. Now, what is a parent chain? I'm going to come back to this example and I'm going to explain what alkyl groups are in a bit more detail. But what are parent chains? Remember, if you've got a compound, if you've got a hydrocarbon with the chain, and then the chain does that, and then it does that, right? And then all these carbons are surrounded by hydrogens. All these carbons are surrounded by hydrogens. I'm not going to draw in the hydrogens now. Just know that they are surrounded by hydrogens. Remember, 4 bonds around all carbon atoms. Right, now what is the parent chain? The parent chain is the longest chain that forms the compound, or the longest chain in the compound. What do I mean the longest chain in the compound? Well, it is the longest connection of carbon atoms, the longest line of connected carbon atoms that you can form in that chain. In this case, what is the longest line? It has to be a chain, so there has to be no discontinuity. It can't break anyway. If I draw a line through here, right, how many carbon atoms do I cut through? I cut through 1, 2, 3, 4. So the chain length in this direction is 4 carbon atoms, right? Now, which other chain do I have? I have this without breaking the line, breaking the line. This is another chain that I have. It's a line that I can draw through successive carbon atoms. How many carbons do I have in this chain? I've got 1, 2, 3, 4, 5. Okay, so now 5 is bigger than 4, so this is my biggest chain. Therefore, this is my parent chain in this compound, right? this is my parent chain, and this is a branch in the chain, right? It's attached. By the branch, I mean it's just a compound that is attached to the parent chain. So the parent chain is the longest chain that is formed out of successive carbon atoms in the compound. Okay, so that's very important to understand for this concept. So that we're going to look at right now, the alkyl groups. Now let's go back up there and continue looking at that compound that I drew in for alkyl groups. Now if you look at this compound here, where is my longest chain? Well, my longest chain is either that, because I cut through 1, 2, 3 carbon atoms, or my longest chain is here, where I cut through 1, 2, 3 carbon atoms. Now, it doesn't really matter which chain you choose in this particular example, because because both chains have 3 carbon atoms. Now, but why am I talking about chains, and why am I talking about all these things here when all I have to do is explain what alkyl groups are? Well, if you look at this thing here, if I have to identify a parent chain, right? Say I choose this parent chain. This is the one that you could have chosen this one, doesn't really matter. But if I choose this parent chain, and if somebody comes and asks me, how do you name this thing? We know how to name aliphatic compounds. We know how to name alkanes. We know how to name alkynes, and we know how to name alkenes. But how do I name this compound here? What is unique about this compound here? Well, you'll see that if this is my parent chain, this chain here has that compound attached to it. So this carbon here in the middle has a bond, right? And it is bonded to a carbon atom, which is in turn bonded to 3 hydrogen atoms. Now, this blue carbon atom does not form part of the chain, but rather it is attached to the chain. So we've got to name it in such a way that whoever is reading the name will be able to tell you exactly what is happening with that compound. The person, through just the name, should be able to say to you, okay, you've got a compound with 3 carbon atoms, and those 3 carbon atoms form a chain, but attached to that chain is another group of hydrocarbons, right? It's another group of hydrocarbons. A person has to be able to tell you that. Now, how is that different from alkenes? Let me draw out an alkene down here. Okay, so if I've got an alkene, say I've got 1, 2, an alkane rather, 3, 4, right? I draw out an alkane, and then I've got hydrogen atoms all over here. I've got hydrogen atoms. So that's hydrogen, that's hydrogen, that's hydrogen, that's hydrogen, 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 and hydrogen, H, and H. Now, you will notice that my longest chain in this instance is that, right? Because those are successive carbons that are connected to one another, which I can draw a line through without breaking the line. That's the longest chain. But if you look at this thing, if you look at this carbon, look at that carbon, you look at that carbon, and you look at that carbon, all of these carbons are surrounded by hydrogen atoms, with the exception of the bonds in between the carbon atoms. All of them are surrounded by hydrogen atoms, all of them. Now, what an alkyl group does is that it takes one of the hydrogen atoms away, and it replaces the hydrogen atom with a hydrocarbon. So C, and then H, and then H, and then H, and then you will see now that I still have this as my longest chain. This is still my longest chain, right? But attached to my chain is another group of hydrocarbons. So suddenly I have an alkyl group. Okay, that is what makes an alkyl group. An alkyl group is simply an attachment of a hydrocarbon to a parent chain. What is a parent chain? A parent chain is interconnected carbon atoms that form a straight line, or that form a continuous line. It might not be straight, but rather a continuous line. So even here you can see that the chain has 4 carbon atoms, right? 1, 2, 3, 4. It has 4 carbon atoms, but it could have gone this way. 1, 2, 3, 4, right? Let me just draw that properly. 1, 2, 3, 4. Because this is connected to that, and that's connected to that, and that's connected to that. So it's still a chain, In this case, then our branch would be that, because that would be connected to this chain. Okay, hopefully that makes sense. Okay, so that's what alkyls are. So alkyls are compounds that have a parent chain of hydrocarbons that have a branch of hydrocarbons. Notice it's still just hydrocarbons. What do I mean? It's still just a compound made up of carbon atoms and hydrogen atoms. The only difference between what I've drawn here and alkanes, for instance, is that alkanes don't have a branch that consists of carbon atoms. All the branches in an alkane or in an alkene or in an alkyne, pure alkene or pure alkane or pure alkyne, all the branches are connected to just hydrogens, not to a hydrocarbon, to just hydrogens. Okay, so if this was an alkene, this is what you would have, and then therefore you still have the parent chain, but you don't have an alkyl group. Why don't you have an alkyl group? Because you don't have a branch that consists of a hydrocarbon. Okay, now that's what alkyl groups are. Now let's do a bunch of examples so that this makes more sense. Okay, that was just the concept. That was the basically the theory. Let's just do a bunch of examples. There's nothing complicated beyond what I've just explained. The naming is actually algorithmic. So you just follow procedure, and you will see that it's just an algorithm that you have to follow. And then I will teach you that algorithm right now. Okay, so I'm going to start off with the example that I had initially. So that is C, and that's C, that's H, that's H, that's H, that's H. Remember, 4 bonds around all carbons at all times. I'm going to keep saying this in each and every single video. 4 bonds around all my carbon atoms. Now let's name this thing. Now you will remember from previous videos, that when we name these compounds with specific functional groups, we have to number. We have a numbering system that we have to follow. So we have to number our carbon atoms. How do we number our carbon atoms? We number it such that the smallest number is closest to the functional group. So from left to right or right to left. But first, let's identify our parent chain. Our parent chain, remember, is just successive carbon atoms that are connected to one another that form the longest chain, right? So I could have this as my parent chain, or I could have this as my parent chain. In this case, I'm gonna name both the compound for both instances, just to show you that just to show you how to do it. Okay, so let's say I start off with this one. Let's say this is my parent chain. So how am I gonna number this thing? I'm gonna say 1, 2, 3. Remember, you number your parent chain from left to right, or end from right to left, right? So this is gonna be 1, 2, and 3. Why are you numbering from left to right and right to left? You want to number it such that the smallest number is attached to your functional group, or to the carbon that has your functional group, right? That's why you number so that you identify the smallest number that can be attached to the carbon with your functional group. So now, how do you name this thing? Well, for your functional group, for your alkyl functional group, I'm just gonna write that down here. For your alkyl functional group, your prefix, right? Your prefix will be "-ile". It will be your suffix, rather, will be "-ile". So suffix is the last part of a name. So for your alkyl group, the last part of the name will be "-ile". What do I mean? Let's go back to our table. This table that I would really love for you to familiarize yourself with. We remember that 1 corresponds to meth, right? If it's 1, it's meth. Please look at previous videos. If it's 1, it's meth, right? If it's 2, it's if. If it's 3, it's prop. If it's 4, it's but. If it's 5, it's pent, and so on and so forth. Please remember this, right? Now, for alkyl groups in this video, let's for a moment forget about this side of the column. Let's focus on just this side of the column, right? so of the table. So for your alkyl groups, this still applies, right? The left column still applies for your alkyl groups. The left column still applies, but the last part of the name now is -yl, right? For your alkyl groups, it's -yl. So remember I spoke about a name and a surname in previous videos. The name is still the left column. The surname is -yl. So if you're looking at alkyl groups, the last part of the name is going to be -yl. The first part of the name is going to be -meth. So what do I mean? It means that you could have methyl. It means you could have ethyl. It means you could have propyl. Or some people say pyl, methyl, ethyl, propyl, but I'm going to say -yl. Butyl, pentyl, etc., depending on what the compound looks like, what the structure of the compound is. Right. So let's look at a couple of examples. Let's look at this example that I started off with. I said, firstly, you identify your parent chain. After identifying your parent chain, you number your parent chain from left to right, then from right to left. Then the second thing that you do after numbering your parent chain from left to right and right to left, you identify your functional group, right? What is your functional group? In this case, your functional group is your alkyl group. It's the branch that is attached to the parent chain. That is your functional group. It is the branch that is attached to your parent chain. What is attached to your parent chain? It is a carbon. It is one carbon with 3 hydrogen atoms attached to it. It's one carbon with 3 hydrogen atoms attached to it. That is your functional group. Now, this functional group is an alkyl group. We discussed that earlier on in the video. This is your alkyl group, and your alkyl group consists of one carbon atom that has 3 hydrogen atoms attached to it. Now, how do we name this alkyl group? Since this alkyl group has one atom, what do we know about one? We know that one corresponds to meth, right? One corresponds to meth. So we come down here and we say our alkyl group, just our alkyl group, we're not naming the entire compound just yet. We're just focusing on the alkyl group for now. We will go back to the compound, to the entire compound. Let's just focus on the alkyl group first. So we say, okay, cool. Since this alkyl group is our function, it makes this whole compound a functional group of alkyl. What is this alkyl, this branch called? Well, one corresponds to meth. We know that one corresponds to meth, but this is an alkyl. How do we know it's an alkyl? Because we've got our parent chain, and our parent chain has a branch attached to it. So we know that, and the branch consists of a hydrocarbon, right? So this is an alkyl group. If it's an alkyl group, what is the surname? Well, the surname is -yl. The surname is -yl, so I know that the alkyl that is attached to the parent chain is methyl, right? That is that. Okay, but then we also know how to name this, right? We know how to name this from previous videos. This is an alkane. This is basically an alkane with a branch of a hydrocarbon attached to it. So this is an alkane. So how do we name our alkanes? We name our alkanes by counting the number of carbon atoms, right? We're going to combine the two names. Now, this alkane is 1, 2, 3. It has 3. What do we know about 3? We know that 3 corresponds to prop, right? Since 3 corresponds to prop, we've got prop, okay? And how many bonds do we have between successive, what are the maximum number of bonds between successive carbon atoms? The maximum number of bonds is, well, it's a single bond. There's no double bond anywhere. There's no triple bond anywhere. It's a single bond. That's our maximum number of bonds between any two successive carbon atoms. That's 1. So we know that if it's 1, then we've got an alkane. And if it's an alkane, then we know that this compound is propane. Right. Now, what do we have here? We've got two names. We've got an alkyl group and we've got an alkane. We've got an alkyl group and we've got an alkane. Now we've got to find a way to combine those two into one. How do we do that? Well, firstly, you've got to remember you numbered your parent chain, right? I'm going to do more examples. It's going to make sense as I do more examples. You numbered your parent chain. As you numbered your parent chain, the reason you numbered your parent chain is that you wanted the carbon that has your functional group to have the smallest number, right? Now, what is the smallest number that is attached to the carbon with your functional group? Firstly, where's your functional group? Here's your functional group. It's your alkyl, right? This is your functional group. So, which carbon is that functional group attached to? It's attached to the C, right? Since it's attached to the C, which is the smallest number that is attached to that C? Well, it doesn't matter if you number from left to right or from right to left. The smallest number is 2. So then this functional group is attached to carbon number 2. Since it's attached to carbon number 2, you're going to say, what is attached to carbon number 2? The alkyl group is attached to carbon number 2. So how you would name this is you would say 2, because carbon number 2 has the functional group. What functional group does carbon number 2 have? It has, if I go back up there, it's methyl, right? It's methyl, so it's 2-methyl. Now, what is this methyl that is attached to carbon number 2 attached to? It is attached to propane. Propane. So this is 2-methyl propane. That is the name of this compound. Okay, that is the name of this compound. Let's do another example. Because I was going very slowly there because that was the first example that we did. But now I'm just going to increase the pace a little. But I'm just gonna, it's very easy. Okay, so now let's say I've got C, and I've got C, and I've got C, and I've got C, and I've got C. Or firstly, before I do this example, let me just do the same example, but identify a different chain, right? So I've got that, and I've got that, and I've got H, got H, got H, got H, got H, I've got H, H, I've got H. How do we name this compound? Well, first step, we identify the longest chain. Where is our longest chain? It's either this one, because I have 1, 2, 3 carbon atoms, or it is this one. I've got 1, 2, 3 carbon atoms following one another, or it is this one, right? 1, 2, 3. Doesn't matter which one you choose. I'm going to choose this one as my longest chain. Okay, cool. That's my longest chain. Now you number your longest chain from one end to the other, and then from the other end to the one, right? So I'm going to say 1, 2, 3, right? And 1, 2, 3. Okay, cool. This is my chain, and I've numbered it. Now, what functional group does this fall under? Well, if this is my chain, what is the branch? The branch is anything that does not form part of the chain, right? So it is that. It doesn't form part of the chain, right? Even these are branches, but these are just hydrogen atoms, so it's fine. We can ignore them. This is a branch. This branch is made up of hydrocarbons, right? It's made up of a carbon atom and hydrogen atom, so it's made up of hydrocarbons. You've identified it. We know that if I've got a branch that is made up of a hydrocarbon, then I've got an alkyl group. If this is an alkyl group, what alkyl group is this? Well, I'm going to have to identify the number of carbon atoms in the alkyl group. How many carbon atoms does it have? This branch has 1 carbon atom. Remember, I'm not looking at the chain. I'm looking at the functional group, which is the alkyl groups. How many carbon atoms does it have? It has 1 carbon atom. If it has 1 carbon atom, what do I know about 1? If I go back to the table, 1 is here. 1 corresponds to meth, right? 1 corresponds to meth. If 1 corresponds to meth, then I'm going to come down here. Then I'm going to write down meth, right? This is meth. Question number 2. Since this functional group is an alkyl group, what follows the meth? What follows the meth? Well, what follows the meth for an alkyl group is alkyl, right? If it's an alkyl group, alkyl follows the meth. So then I've got methyl. Right, now what is this alkyl group attached to, right? What aliphatic compound is this alkyl group attached to? Well, it's attached to, firstly, what kind of aliphatic group am I dealing with? Is it an alkene, an alkyne, or an alkane? Well, the maximum number of bond between any two successive carbon atoms is 1. Right? I've got a single bond here, and I've got a single bond here. So since the maximum number of bond between two carbons is 1, right? There's no bond that is more than 1. It's one bond. Then it means that I'm dealing with alkanes, right? Because if I'm dealing with alkanes, I've got one bond between carbon atoms that follow one another. If this is an alkane, okay, cool. Now I know that I'm dealing with an alkane. What alkane is this? Well, how many carbon atoms does it have? It has 1, 2, 3. This is the parent chain, right? The parent chain has 3 carbon atoms. So I know that for 3, what corresponds to 3 in my table? If I go back to my table, there's my 3. 3 corresponds to prop, right? 3 corresponds to prop. So I come back down here and I say prop. I'm going to write prop here. And this is an alkane, right? Because single bond everywhere. So then this is propane. Okay, cool. Now I've got two names that I need to combine. How do I combine them? Well, I know that I've got a propane that has a branch of methyl. I've got a propane which forms my parent chain, and attached to that parent chain is my methyl, right? So on which carbon number is my methyl attached to? The smallest number that is corresponding to the carbon that is attached to your methyl, or that the methyl attaches to, is 2, right? I've got 2. 2 and 2 are surrounding this carbon atom. 2 is the smallest number on the carbon atom that has that branch, meaning that the methyl group is on carbon atom number 2. Since it's on carbon atom number 2, what do you say? You say 2 dash, because it's on carbon number 2. What is on carbon number 2? Well, we just identified that this is methyl. Methyl is on carbon number 2. So we're going to say 2 methyl, right? 2 methyl. Now, this alkyl group that's on carbon number 2 is attached to what parent chain? Well, the parent chain is propane. We just identified that it's propane. So this is going to be 2 methyl propane. Okay, easy peasy. Nothing complicated with that. Okay, and you will notice that the name is identical to this name, 2 methyl propane, which is what we got when our parent chain was this. This was our parent chain and this was the branch. Exactly the same answer, exactly the same thing. Okay, so that's how you would name that. Let's do another example. So we've got, let's try to come up with another example quickly. C, and C. Okay, still an easy example. The names can get long, not complicated, just long. Still very easy, just long. Okay, we might cover that on a separate video if I don't get the chance here. So that's that, and that's that. Okay, cool. Now, how do you name this compound? First step, identify your longest chain. Okay, your longest chain is the longest length you can go where your carbon atoms are connected. I've got 1, 2, 3, 4 here. I can also have 1, 2, 3, 4 here. So it doesn't matter which one you choose as long as the chain is long, right? What I'm going to do is I'm going to choose this chain here, right? And I'm going to number it from left to right and right to left. So I choose this chain, so I'm going to number it like that. 1, 2, 3, 4. 1, 2. Actually, let me write it here. 2, 3, 4. Cool. I've identified my longest chain. Now, what is attached to my longest chain? Well, I can clearly see that there's a hydrocarbon that is attached to my chain, to my parent chain. Therefore, this is an alkyl group. Why is it an alkyl group? Because I've got a hydrocarbon attached to my parent chain. I've got a compound made up of carbon and hydrogen and hydrogen and hydrogen that is attached to my parent chain. So therefore, this is an alkyl group. And how do I name it? Well, I say, okay, firstly, if this is an alkyl group, what is the alkyl, right? How do I identify the alkyl? Well, you look at the branch and you look at the number of carbon atoms that it has. How many carbon atoms does it have? It has one carbon atom. So you go to the table, hopefully you know it off by head. There's one carbon atom, corresponds to meth. Since one carbon atom corresponds to meth, just right quick. So you've got meth, right? You've got meth, and I know that this is an alkyl group. If it's an alkyl group, what is the last part of the name? It's methyl, right? Yl is methyl, right? Now, what is this methyl attached to? Well, it is attached to this parent chain here. Now, what is this parent chain made up of? Well, it's made up of a hydrocarbon that is made up of single bonds. If it's made up of single bonds, what do I know about a hydrocarbon that's made up of single bonds? If I go to the first page, single bond, alkane. So it's an alkane, right? It's attached to an alkane. If it's attached to an alkane, what alkane is it attached to? Well, how many carbon atoms does the alkane have? It has 1, 2, 3, 4. It has 4 carbon atoms. If it has 4 carbon atoms, you go back to your table. Very easy. You've got 4. There's your bute. 4 corresponds to bute. You go down, go back down here. You say, okay, bute. And we said it's an alkane, therefore it's butane. If it's an alkane, it's butane. Now I've got 2 names that I want to combine. How do I combine them? Well, I identified, remember I numbered my parent chain. I said 1, 2, 3, 4 from left to right. And I said 1, 2, 3, 4 from right to left. Now, the smallest number that your branch, this is your branch, the smallest number that your branch is attached to is the number that you're going to use in your name. Now, which smallest number are we looking at here? Well, here's the carbon atom that has a branch, right? There's the carbon atom that has a branch. What is the smallest number that is attached to that C? Well, the smallest number is 2. So how do we name this? How do you combine these two? You just say, okay, the smallest number is 2. What is attached to carbon number 2? It's methyl. Okay, it's the first name on top. And what is it attached to? It is attached to butane. Okay, you see how quickly I can do this thing? It's very easy. It's not complicated at all. Let's do it again. Let's do it again. Let's do another example. Okay, let's make it a bit different now. Let's say, see if I can come up with a different example. You've got C, 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 then you've got H, 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 H. Got H everywhere. H everywhere. Okay, so I've got H everywhere. Let's see. Now, how do you name this? Let's see. I want to do it differently. Let's do this. I'm gonna put in more C's because I want to show you. I want this. And then I'm gonna do here. This is C, this is H. Okay, I want this to be a very specific example. Okay, cool. So let's do this example. Okay, I was very intentional about this example. I want to, there's something specific that I want to show you. Okay, so I've got a bunch of C's and I've got a bunch of H's here. How do you name this thing? It looks complicated, it looks complex. It's not at all. We follow the exact same procedure that we've been following this entire time. So let's do that. Right, so step number 1, how do you name this thing? Well, firstly, identify your parent chain. What is your parent chain? Your parent chain is your longest chain, right? What is your longest chain? Is the longest chain that you can have where your carbons are connected to each other without a discontinuity, right? Without a breaking point or break in the chain. So I could have this as my chain. I have to find the longest one. Or I could have that as my chain. It's obviously not this. This is a short chain. So let's see which is my longest chain. See here, I've got 1, 2, 3, 4, 5, 6, 7, 8, a chain of 8 carbon atoms, right? This is a chain. Ooh, load shedding. A chain of 8 carbon atoms. Now here, what about this one? 1, 2, 3, 4, 5, 6, 7, 8. I've also got a chain of 8 carbon atoms. So it doesn't really matter which one I choose, right? It doesn't matter which one I choose. I could go this way or I could go that way. I like to keep it straight. I like to keep things as simple as possible. You know, the simpler you can keep things, the less you make mistakes. So I want to choose this one because it just looks nice. Doesn't matter though, you could have choose the other one if you're feeling like you want to do something different. Okay, so now I'm going to number it. Step number 1, identify your longest chain. I'm going to choose this one. Longest chain identified. Done. Step number 2, number your chain from left to right and then from right to left. So from left to right, that's 1, 2, that's 3, that's 4, that's 5, that's 6, that's 7, that's 8. And then from right to left, that's 1, that's 2, that's 3, that's 4, that's 5, that's 6, that's 7, and that's 8. Okay, cool. We've done step number 2. Remember, step number 1, identify your longest chain. Done. Step number 2, number it from left to right and from right to left. Done. Step number 3, identify your functional group. Well, I've got my chain. There's my chain, right? There's my chain. What is attached to my chain or my parent chain? Well, I've got this entire thing that's attached to my parent chain. I've got this entire thing. What is this thing that is attached to my chain? Well, it's a group of hydrocarbons. It's hydrocarbons. It's a compound made up of carbons and hydrogens, right? And hydrogens. So it's a hydrocarbon. So if I've got a parent chain and I've got a hydrocarbon attached to my parent chain, what functional group am I looking at? Well, I'm looking at an alkyl. I'm looking at an alkyl group. So if I'm looking at an alkyl, what alkyl is attached to my parent chain? That's your next question. What alkyl? If I'm looking at, you say I'm looking at an alkyl, what alkyl is it that is alkyl group is it that is attached to my parent chain? Well, how many carbon atoms does the alkyl group have? So it has 1, 2, right? It has 2. Now, what do we know about 2? Go back to our table. There's our 2. Here's our 2 here. Our 2 corresponds to if, right? 2 corresponds to if. So then I'm going to say if is my alkyl group. Since my alkyl group has 2 carbon atoms, I know that it's ethyl, right? Because it's an alkyl. Alkyl has "yl" in the end, right? Now I know that's the first part of my name. What is the second part of my name? Well, if I look at this compound here, my alkyl group is here. What is left is my parent chain. Now my parent chain is made up of let me just remove this line. It's made up of carbon atoms that are connected with single bonds throughout. It's single bonds everywhere, single bonds everywhere, single bonds everywhere, right? Single bonds each and everywhere. If I've got single bonds, carbon atoms connected by single bonds everywhere, I'm dealing with alkanes, right? If I'm dealing with alkanes, cool, I know that my alkyl is attached to an alkane, but what alkane is it attached to? Well, how many carbon atoms does it have? It has 1, 2, 3, 4, 5, 6, 7, 8. It has 8 carbon atoms. Since it has 8 carbon atoms, I go to my table and I see that I've got 8 here, and my 8 corresponds to oct. Therefore, this is an alkane, so it's octane. right? It's 8 for oct, and then ane because it's an alkane. How do I know it's an alkane? Because it's single bonds throughout. Single bonds throughout. And because it's single bonds throughout, why do I know about single bonds? Page 1, alkane, single bonds throughout. If it's single bonds, then alkane. If it's an alkane, then the surname will be ane, or the last part of the name will be ane. Therefore, that is oct for 8, and then ane for alkane. Right, now I have to combine these two into one name. How do I do that? Well, the way I do that is that I will look at my numbering on my branch. This is the wrong thing that I'm looking at here. I'll look at the numbering on my branch, which is this one. Here's my numbering. And the carbon that has the branch attached to it has two numbers. The smaller of the two numbers is the number that I'm going to use, right? Which carbon has the branch? In this case, the carbon that has the branch is this carbon. Now, this carbon has two numbers attached to it. Since it has two numbers attached to it, which is the smaller one? The smaller one is 3. So, what is the name of my thing? Well, it starts with 3. On carbon number 3, I've got an alkyl group. What is the alkyl group that I have? It's ethyl, right? I've got ethyl on carbon number 3, and then this ethyl group that is on carbon number 3 is attached to a parent chain. Now, what is the parent chain called? The parent chain is called octane. It's called octane, and that is the name of my compound. Okay, let's do one more, and then I will do a whole lot more. I will dedicate a video. Excuse me. I will dedicate a video to doing more examples because it gets more complicated. There's a lot more, not complicated, just longer. The naming gets longer, but not really complicated. It's still very easy. But let's do one more example. Okay, so if I've got this, and I've got this, and I've got this, and I've got and I've got this, right? That's that. Remember, 4 bonds around every carbon atom. 4 bonds. Okay. There. Let's name this thing. Same procedure, same procedure. How do we name this thing? Well, we say, okay, cool. Identify the longest chain. Which is our longest chain here? Well, our longest chain, I'm going to choose, it could be 1, 2, 3, right? Or it could be 1, 2, 3. Okay, or it could be 1, 2, 3. What I'm going to do is I'm going to choose this as my longest chain. I'm going to choose this as my longest chain. Okay, now that I've chosen this as my longest chain, I'm going to number from 1, 2, 3, and 1, 2, 3. Okay, 1, 2, 3, and 1, 2, 3. I'm going to number it like that. And then what am I going to do? I identified my longest chain as that one. Now that I've identified my longest chain, this is my chain. What is attached to my chain? Well, this is not part of the chain. It means that it is attached to my chain, right? Since it is attached to my chain, what is it? What is this thing that is attached to my chain? It's a compound made up of carbon and atoms. It is a hydrocarbon made up. It's a compound made up of hydrogen and carbon. So hydrocarbon. Since it is a branch that is made up of hydrocarbons, what is it called? It is an alkyl group. It's an alkyl group, right? If it is an alkyl group, what's the next question to ask yourself? Well, which alkyl group is it? How many carbon atoms is it made up of? Just one. Now, what do I know about 1? Go back to your table up here. There's 1. 1 corresponds to meth, right? 1 corresponds to meth, so meth. Okay, and it's an alkyl group, so it's methyl, right? It's methyl. Now, what is this alkyl group attached to? It is attached to this parent chain. Now, what is the maximum number of bonds between two successive carbons in the parent chain? Well, the maximum number is 2 bonds. Okay, 2 bonds. Now, if I've got 2 bonds, a maximum of 2 bonds between 2 carbon atoms, what am I looking at? I'm looking at the alkene group. So, I'm looking at the alkenes. So, what alkene is this? What alkene am I looking at here? Well, I'm looking at how many carbon atoms does it have? It has 1, 2, 3. What do I know about 3? I know that 3 is where? Here's 3 here. There's my 3. 3 corresponds to prop. Okay, and it's an alkene. If it's an alkene, it means it has a double bond. If it's an alkene, what is the last part of the name? It's ene, right? It's ene. You can visit previous videos for this. We covered this in previous videos. So I'll go back here. Then I know that it's 3 is prop and ene, right? So I've got pro for 3 and pene because it's an alkene. Now I've got to put numbers to this thing. Firstly, I've got to put these names together, and I've got to identify where, if you look at the previous video, where this double bond is, and from this video, where this branch is. Now we start off with the branch, right? We start off with the branch. Now the branch is methyl, but where is this methyl? Well, here's the methyl here. It is attached to carbon number. The smallest number is 2 around this carbon that has the branch attached to it. So it is attached to carbon number 2. So I know that I've got 2 methyl. I've got 2 methyl, and then I've got this propene here, right? I've got this propene here. Since I've got this propene here, this is my double bond. Now, this double bond is surrounded by 1, 2, 3, 4 numbers. It is surrounded by 4 numbers. Okay, since it's surrounded by 4 numbers, you identify the smallest number of the 4. What is the smallest number? The smallest number is 1. Therefore, this is going to be, from a previous video, it's going to be prop, because I'm dealing with propene, it's going to be prop dash 1 dash, you just break this into 2, so you put the 1 in here in between. Prop dash 1 dash 2. I don't have enough space. Let me just rewrite it down here. So that's your answer. So right, you've got 2 methyl, right? On carbon number 2, you've got your methyl. Then in your propene, on carbon number 1, you've got your double bond. That's all that this name says. Carbon number 1, you've got your double bond. Carbon number 2, you've got your alkyl group attached to it. Easy. That's all this thing says. Okay, so that's how you go about doing this thing. Okay, so I think I'm going to stop here for this video, and on a separate video I'm going to cover a bunch of other examples where you combine different alkyl groups and you can put them on different carbon atoms, and you can have alkynes and alkenes and alkanes and all sorts of combinations. What I need you to understand is that the approach, the procedure is exactly the same thing. We're just going to add 1 or 2 new things in the next video, but the procedure, the steps you follow is the same. You identify your parent chain, you look at what is attached to your parent chain, you name that thing, then you name your parent chain, then you identify the number, the position of the carbon atoms where things take place, and then you combine the name, and then you give out all the information. That's the procedure, that's the steps, those are the steps to follow. Okay, there's nothing complicated about that, but we will cover it on a separate video. Okay, so this was a good introductory video to your alkyl groups, and we will do it more in the next video. Till next time.